हेलो एवरीवन, दिस इज निहाल एंड हम सॉल्व करेंगे क्वेश्चन नंबर 5th डी ऑफ यूपीएससी सिविल सर्विस एग्जामिनेशन मैथमेटिक्स ऑप्शनल पेपर 2 ऑफ 2022. So it is related to mechanics and Lagrangian equation need to be found. So a particle at a distance r from the center of force moves under the influence of the central force, that is F is equal to minus k upon r square, where k is a constant. Obtain the Lagrangian and derive the equation of motion. We need to obtain the Lagrangian L is equal to T minus V, where T is kinetic energy and V is potential energy. Also, we need to find equation of motion. Equation of motion. So let us first discuss about this question. In 2020, there was a similar question on Hamiltonian where force was given as F is equal to minus kr. So in mechanics and fluid dynamics, questions mostly on are similar lines and mostly are repeated. So if you know that a force is given and how to find potential energy, then the problem is solved very easily. So let us first find the kinetic energy. T is equal to, in the polar coordinates of 2D, and the kinetic energy is 1 by 2 mv square, so which is equal to 1 by 2 mv square. V square is in 2D of polar coordinates, it is r dash ka square plus r theta dash ka square. So let us assume that this is equation 1, and let us find V. V is equal to minus delta V upon delta R is equal to F. So remember this thing. So minus delta V upon delta R is equal to F. That implies minus delta V upon delta R is equal to minus K upon R square. This minus minus is cancelled, and let us integrate this. So V is equal to integration K upon R square dr is equal to minus K upon R. Let us for the moment ignore the constant of integration. So this is V. So Lagrangian is equal to T minus V. So this is equal to T is, what is T? T is kinetic energy 1 by 2 m V square. V square is R dash ka square plus R theta dash ka whole square and plus K upon R. This minus K upon R will become plus because of this minus sign. So the question asks us to find the Lagrangian. So this is the Lagrangian. Now we need to find the equation of motion. So Lagrangian equation of motion is d upon dt delta L upon delta Q alpha dash minus delta L upon delta Q alpha is equal to 0. Here it will be 0 if the force is conservative. And let us assume that this force is conservative. If the force like frictions are given, these forces are not conservative. So if the force is conservative, so there are two generalized coordinates, that is r and theta. So first let us assume that k alpha is equal to r. For this we need to find the equation of Lagrangian equation. So d upon dt delta L upon delta r dash minus delta L upon delta r is equal to 0. What is L? L is given by this. So what will be delta L upon delta r dash, which is equal to 1 by 2 m. This r dash square will become 2r dash, and rest is 0 because there is no term of r dash here and no term of r dash here also. So it is this. and delta L upon delta R is equal to 1 by 2 m 2r theta dash ka square and minus k upon r square. Let us put these two in the equation. So d upon dt 1 by 2 m, this is 2r dash, minus delta L upon delta R is 1 by 2 m 2r theta dash ka square, and this will become plus k upon r square. This minus and this minus will become plus, is equal to 0. So by simplifying d upon dt, this will become m r dash minus this is cancelled, so minus m r theta dash ka square plus k upon r square is equal to 0. So this can be written as m r double dash minus m r theta dash ka square plus k upon r square is equal to 0. Let us assume that this is equation 1. Now we need to find the similar equation for q alpha is equal to theta. Here theta and r are generalized coordinate for this given system. So for that, d upon dt delta L upon delta theta dash minus delta L upon delta theta is equal to 0. So we need to find delta L upon delta theta and delta L upon delta theta dash from here. So delta L upon delta theta dash is equal to 1 by 2 m r square 2 theta dash, and delta L upon delta theta is equal to 0. So let us put these two in the equation. This 2 will be cancelled, so m r square theta dash. So this implies d upon dt m r square theta dash minus 0 is equal to 0. That implies this m can be taken outside, m d upon dt r square theta dash is equal to 0, which is d upon dt. Since m is not 0, so this is 0. So r square theta dash is equal to 0. This is equation 2. So 1 and 2 combined gives the equation of motion for the given system. So this is the solution of fifth D. Thank you guys. Thank you very much. Link of Telegram group is mentioned in the description. You can join that group and you can